Alright, so there is a theorem that will allow us to use the inverse of a matrix to solve a system of equations. So if A is an invertible matrix, then the system of linear equations Ax equals B has a unique solution given by x is equal to A inverse times B. Note that this theorem applies for square systems, that is, having the same number of equations as variables. Also take note that the first premise here is that if A is an invertible matrix, which would mean that if A is not invertible, then we cannot use this solution. Let's have an example. We are asked to solve this system using an inverse matrix. So first, let's write it on the form Ax equals B. So that would mean we'll have 2, 3, 1, the coefficient matrix, 3, 3, 1, then 2, 4, 1, multiplied to its variables, x, y, z, is equal to negative 1, 1, negative 2. According to the theorem, we can solve the value of this matrix X by multiplying the inverse of A to B. So therefore, X, Y, Z would be equal to finding the inverse of our coefficient matrix. There you go, multiplying it to our constants. Finding the inverse of this matrix is left to the viewers, and this matrix has an inverse. This inverse exists, and this is actually, when you compute it, negative 1, 1, 0, negative 1, 0, 1, and 6, negative 2, negative 3. Once you multiply it to the constants negative 1, 1, and negative 2, you're going to have the following column matrix: 2, negative 1, negative 2, which is equal to your x, y, z matrix. By the equality of matrices, we say that x equals 2, y equals negative 1, and z equals negative 2. Let's have another example. This time, it's your turn. Pause the video and try to see if you'll be able to solve this system by finding the inverse of a specific matrix. Alright, so first, we shall write this again in the form Ax equals B. So therefore, we'll have our coefficient matrix 2, 3, 1, 3, 3, 8. Oops, let's write that a bit farther. 3, 3, 8, 2, 4, 5. Multiplied to x, y, z, then is equal to 4, 8, 5. So that would mean the matrix x, y, z would be equal to the inverse of the coefficient matrix. Oops, sorry, this should be 1, not 8. That is also 1, actually. So let's change this also to 1, 2, 4, 1. Find the inverse of that, then multiply it to the matrix of the constants. And this is actually the same matrix as the previous example, so we know that its inverse is negative 1, 1, 0, negative 1, 0, 1, 6, negative 2, negative 3, and you multiply it to 4, 8, and 5. Oops, that is 5. Let's just change that. 8, then 5. Then this will be giving us, let's bring that down. There you go. This will be giving us 4, 1, negative 7, which is equal to your matrix XYZ. And by equality of matrices, x equals 4, y equals 1, z equals negative 7. And that's using the inverse of a matrix to solve a system of equations.